Hello everyone, welcome to Let's Learn Analog Electronics with Sijo. First, let us define what is electronics. Electronics is the study of how electrical signals are controlled using electronic components to perform useful tasks. If you see in this definition, we have got the word electrical signal. Electrical signal, like what? Like current, like voltage, is controlled by using what? Electronic components. We have got various electronic components, which are what? Resistors, inductors, capacitors, amplifiers, etc., etc., in which we use these electronic components to perform useful tasks. This is what we call electronics. We can branch these electronics into two parts. That is analog electronics and digital electronics. But in this lecture, we are more interested in analog electronics. So let us define what is analog electronics. Analog electronics is a branch of electronics that deals with electrical signals that vary continuously with time and uses electronic components and circuits to amplify, to process, or to modify these continuous signals. So when you hear analog electronics, what must come into your mind is to know that I have got a continuous signal which I need to manipulate, by the use of what? Of electronic components. The components that we mainly use to manipulate these continuous signals in analog electronics are what? We can use amplifiers, we can use diodes, we can use capacitors, we can use resistors. Okay? So let us look into this diagram, which shows a continuous signal, which varies between negative A and A, which is amplitude. As time varies, this amplitude is also varying. So what is a signal? A signal is an electrical quantity that carries information. An electrical quantity, voltage, an electrical quantity, current, which carries what? Information. It carries information maybe in terms of numbers. Let's say we've got 1,2 volts. I've got a signal of 1,3. I've got a signal which varies between 0 and 0,6. I've got a signal which varies between 0 and 5. Okay? An analog signal is an electrical quantity that varies continuously with time and can take any value within a given range. That is the reason why I have already drawn this diagram with a amplitude varying from negative A and A. If you see on this diagram, let us see it clearly, we have got an analog signal which varies between negative 1 and 1. Maybe this is current. Let's say this is current. We've got an alternating current which varies between 1 and negative 1. Let's say in amperes, negative 1 ampere or negative 1 ampere or 1 ampere. This signal, this current is varying from 0, it goes to 1, it comes back to 0, it goes back to negative 0, something, 0, something up to 1, it goes back, it goes back to 0, it comes again to 1, and continuously. So you can see that as time is changing, the amplitude of this alternating current is also changing. What are the examples of analog signals? We have got a microphone. A microphone, let's say a musician is singing, he puts a sound pressure into a microphone. This microphone, it outputs a output voltage which changes with the sound pressure, which is being what? Put by what? By a musician. Again, another signal is an ECG signal. This signal, it represents the heart electrical activity. It's also an analog signal. We've got temperature sensor. A temperature sensor, it outputs the voltage which varies with what? With time. And these signals are always continuous, meaning that the amplitude is continuous and also the as what as time is varying. Okay, now let us define digital signal. What is a digital signal? A digital signal is a signal that represents information using discrete values of amplitude and a discrete instance of time. This is where it differs with what? With analog signal. In digital signal, we have got discrete values of amplitude and what? At discrete instance of time. For example, if we look at this diagram, this graph, you can see that these graphs, we have got an instant time of t0. Our amplitude is what? Is 1. And at t is equals to 1, the value drops backward to 0. And at t is equals to 2, the value goes again to 1. You can see, to represent it clearly, I have drawn another diagram so that you can see it clearly. At t0, we've got a value of 1. At t1, we've got a value of 0. At t2, we've got a value of 1. At t3, we've got a value of 0. At t4, we've got a value of 1. At t5, we've got a value of 0. Written here, t0 is equals to 1, t1 is equals to 0, t2 is equals to 1. So you can see that at each instant of time, we have got a discrete value of amplitude. At t0, we have got a discrete value of 1. It differs with analog signal. In analog signal, we have got continuous values. But in digital signal, we have got discrete values of amplitude and at discrete instance of time. You can see in this graph that, let's say here, from between t0 and t1, what is the value between t0,5? We do not have a value at t0,5. We can say that our signal is not defined. This signal is undefined at t is equals to 0,5. Okay? Let us now differentiate between analog and digital signal. If you look at this table, you can see definition, a signal that varies continuously with time, that is an analog signal. A signal that varies in discrete step, that is digital signal. Time is continuous in analog signal. And time in digital signal is discrete. That's why we say at t0, at t1, at t2, at t3. Amplitude for an analog signal is continuous. Let's say between -1 and 1. At each and every time, we have got a value. But in digital signal, it's discrete. Amplitude is discrete. And we know that noise effect of an analog signal is highly affected by noise. But in digital signal, it's less affected by noise. Why is it like this? Because in analog signal, since we have continuous signal, any slight change which is caused by noise can affect our signal. Okay? Again, we've got distance, accuracy over distance between analog signal and digital signal, where in analog signal it degrades the distance, but digital signal it maintains quality over time. You can pause this video and have a look at this diagram between analog signal and digital signal. Subscribe, share, like, comment, and let's learn analog electronic with Zijo. Thank you.